Okay, so we it's a bit late in the day, and so we move into something a bit lighter. Not, I've been entertained. I think the previous talks have also been entertaining, but this is going to be less formal. And it's very nice, of course, that we had Chris to uh, give the grounds because I've been talking basically about the same theory, but focusing on this notion of active information. And this is so the period when I interacted more close with Bohm was maybe like from 1984 till 92, when he died. And so I can say that at that period, Bohm was very interested in this what we call the Bohm theory. The 52 approach, which they then were developing further with Basel. And of course, there was the implicate order as well, but somehow, at least in our interactions, he's really keen on this one. And maybe there was a sense that he felt that this was some, theory when it came out in the 52, the response wasn't that great. And then, due to Bell, but also people like Chris Dewey and others, and somehow I think he got again very interested in this. So in that sense, Bob wasn't calling it the Mickey Mouse theory, although maybe he also felt that then one wants to go to a more general and deeper picture. Okay, and so my question is whether active information can solve key problems in the Bohm theory. So let's see. Let's see what the problems are. This is just a very briefly summary. I don't need to do that because Chris already presented it. But anyway, so the aim of this theory, and it was to develop an ontology that is consistent with quantum theory, theory of what exists. It begins by assuming that the electron is a particle always accompanied by a wave or field, satisfying Schrodinger equation, and then this wave determines quantum potential. And note that especially if you look at the 52 version, the theory postulates that an electron is particle and a physical field, a bit like electromagnetic field. So at that time, Bohm was still, in some ways, thinking perhaps more traditional ways. There's a quantum, the wave function is describing something physical. But you could argue that this way of thinking gives rise to problems which Bohm himself later acknowledged. He himself, as we will see, he himself called the mathematical form of the quantum potential strange and arbitrary. People like Shelley Goldstein would agree, he would still refer to this. Also, this connects to Chris' talks. The quantum field for the many-body system lives in a multidimensional configuration space. And then if you're kind of realist about this physical field, then you find yourself being realist about the configuration space. And there's actually, it's not just in the Bohm theory, there are a lot of other people, David Albert, Alison A, who actually has taken a lot of metaphysics of quantum theory today. It's a big topic, what to make of this. It's called wave function realism, but it really refers to this, that one is realist about the configuration space. And of course, that is, if you take it literally, it's very different. Every day, ontology is three-dimensional space. Maybe with Tuomo, we might have the fourth, but here you have 3n. Okay, and then you see, then also in the Bohmian theory, Bohm's theory of measurement, what happens is that you at the end of the measurement, you find the particle in one of the wave packets, but then there are these empty packets. And physicists don't like it. They think that the Bohm theory leaves all these bits of reality floating around. Some people actually say that the Bohm theory is many worlds in a closet. But anyway, we don't go there. Now, but you see, what happens, and this is the time, of course, when I was interacting with the Bohm, so that's what so this stuff is what we were really talking a lot about. So what he did, maybe late 70s, early 80s, he would propose that the quantum field is not an ordinary physical field, but rather a field carrying what he called active information. And you see, and this way he claimed to make sense of the strange mathematical form of the quantum potential, make sense of the multidimensionality of the many-body quantum field, or if you like, configuration space, solve the problem of empty wave packets, and actually, as a bonus, open up a new way of understanding the relation between mind and matter. And this is actually the bonus is the one that I've been working. So I did my PhD in '92, using the Bohm theory, active information, to discuss mind and matter in philosophy of mind. But anyway, and you see that the interesting thing is that this active information is it's sort of ignored by, for example, I don't think the Bohmian mechanics group wants to hear about it. It comes from the second order picture, like Chris was saying, and it's anyway a little bit weird somehow that so it's mostly dismissed by the Bohmians, even by the Bohmians. Peter Holen does mention it, acknowledge it in his book, and a few people here and there do that. But you see, what I want to make clear that actually maybe we shouldn't dismiss it, because maybe with this notion we can actually solve the problems in the physics. Okay, and that's kind of the way one of the reasons. So Bohm wasn't just doing it for fun. I mean, it's kind of you will see it's a kind of an exotic notion. I mean, Bohm had a lot of fantasy, so he introduced all kinds of these notions, even playful notions at times. But here you can see that actually it does some real work for physics, and this is then what I share with you. And of course, I'd be more than happy if anybody has then feedback either after the talk or later on. Okay, so this is just very quickly reminders. So what was the nature of the quantum field, of the quantum wave, initially for Bohm? And so here he would say that this is just the saying how he argues that actually the wave function of an individual electron is a mathematical representation of an objectively real field. So of course today this is called psi-ontic. So he's realist about the wave function. Okay, the wave function is describing something objectively that exists out there. Okay. And again, he would use terminal. This is all from the 52 papers. The field exerts a force analogous to the way electromagnetic field exerts a force. Okay. And he would argue there's no reason why a particle should not be acted on by a psi field, as well as by other fields. Even there could be fields we have discovered. And so again, here is this. The idea of quantum potential. So there's the quantum potential on the expression on the right side. And now you see, but in later work, this is from this was published in 1962. It's published in the book Wholeness and Intricate Order. But anyway, so he's there starting acknowledging problems. He would say, it must be admitted that the notion of the quantum potential is not entirely satisfactory, because then he would say that the proposed form, the mathematical form, is strange and arbitrary. It has no visible source. And then he says it's still this is a logically self-consistent structure, but plausibility suffers. Okay. So he's kind of worried. So what do we do? Well, we cannot be satisfied with accepting such a potential in definitive theory. It's more like a schematic representation of some more plausible physical idea that we can find later on. Okay. Now the second problem is, this connects to what Chris was talking about, the configuration space. And if you look at the many-body system, then in this case, the Schrödinger equation doesn't describe a wave in ordinary three-dimensional space, but instead a wave in an after three n-dimensional space, where n is the number of particles. And this is just explaining configuration space. So a point in three-dimensional space can be described by three numbers, which are its three coordinates. And then you can keep on going and so that it's more generally a three-n dimensional. So you add three dimensions for each particle in your system. And you get this very multi-dimensional space. Now he would say again, fair enough, this is logically consistent, but he says this procedure is not really acceptable in the physical theory. So he was not a fan of this configuration space realism at the time. Again, the same thing as with the quantum potential. It's something that we use now and waiting for the day when everything is expressed once more in ordinary three-dimensional space. So it's clear that that's what he was really at that time. This is actually a 57 book. He was still reading of this. Okay. Now then, this is something which I sort of discovered more recently, but and this is from Bowman-Hiley book, The Adiabatic Universe. It's just about, you see, this is what happens in a measurement. So, so the way they describe measurement is that this you have the measuring apparatus and observed system. They will have this a wave function for the combined system, but then when they interact, they will break into the sum of non-overlapping packets, each corresponding to possible results, and then the this will be then magnified by some detecting so that it's observable. I think they're taking a bit like the von Neumann style measurement here. And you see then, okay, once the wave packets have separated, the apparatus particle must have entered one of them, in which it remains indefinitely since the probability of being between packets is 0. So of course they're accepting the probability imputation as well. And the other wave packets are unoccupied, that is empty. And you see now, people don't like the empty wave packets. You see, those who are accustomed, and why? Well, in the usual independent quantum theory, a lot of people think that I don't go there yet. So for those who are accustomed to the conventional independent quantum theory, the notion of empty wave packets arising naturally in transition processes and artificial measurement process may not seem to be acceptable. So it just say that people don't like it. Of course, the way Bowman-Hiley do it, that they first do transition processes, and then they just say that measurement is a special case of those processes. Okay. But you see, so why don't they like it? Well, because the conventional interpretation, this would be maybe people like, the von Neumann approach, and that the wave function corresponds to the actual state of the system, and as such constitute the basic description of reality. I mean, you may remember people say that the wave function is a complete description of the quantum object. Okay, so it's description of reality. And you see, so therefore, if you have these empty wave packets, which you have in the Bohm theory, so you have all these bits of reality floating around, interpenetrating that part of reality which corresponds to the occupied packets. So this is kind of, people don't really like that. Okay, so we got these three problems. The strange form of quantum potential and the multidimensionality, and then empty wave packets. So let's see, go to the solution, the way I think Bohm himself felt we can solve these things. Okay, so you see what he did was to propose that this quantum field is not an ordinary physical field, but it's something that carries what he called this active information. And now we can see whether we can actually solve these problems. And as a bonus, even the minor matter. So we got to get what else we solve. Okay, this is a slide from Basel, just showing you the way this works. Is the pointer in the middle?
Yeah, I think so.
So there you see this form of the quantum potential again, and so and this is the two slit. And of course we saw Chris so I was saying here. Now one thing is, how does the active information idea arise? Well, first thing, Bohm then looked at this mathematical expression, and he noted that Q is not changed when we multiply the field intensity R by an arbitrary constant. So R is the amplitude, absolute value of the wave function, okay? And so why not? Well, this is because R appears both in the numerator and the denominator of Q. So you see, it's the size doesn't matter here. See? And so the effect of the quantum potential, so it's independent of the strength or intensity of the quantum field and depends only on its form. Because you can see it here, it's the second spatial derivative, which is really the way the formal curvature of R. And you see, whereas in classical waves, it's they always have this effect that's proportional to the strength of the wave. And so, what then they use is this radio wave analogy. So they will say, if you think of a ship on autopilot, the effect of the radio waves are not pushing and pulling the ship, but it's actually the effect depends only on the form of these radio waves. Okay? And so the point here is that the ship is moving with its own energy, and information in the radio waves is then directing the much greater energy of the ship. And now Bohm highly argue then that the electron too moves under its own energy, and this information in the form of the quantum wave directs the energy of the electron. Okay? So that you get these kind of new features, like we saw the way, of course, you can think of this in terms of quantum potential, but you get all these the kinds of trajectories that Chris was going to non-classical trajectories, okay? And you see, and you get things like kind of the way the environment can, the form of the environment, the distant features can profoundly affect the movement. So so there's kind of a wholeness. It's kind of reminiscent in some ways of Niels Bohr's ideas, but it's the same. Of course, this is more explicit. Now, and the basic idea of this notion, they then generalize and suggest this notion of active information, where a form having very little energy enters into and directs a much greater energy. And then the activity of the greater energy is given a form similar to that of the smaller one. And so here, of course, we are using the word information as literally putting form into forming. This is the etymological meaning. And so let's see whether we can solve the problems with this notion. So the first problem is that if you think of this the strange form of quantum potential, well, if you accept this interpretation, it's no longer, well, it may be still be strange, but anyway, it now reflects a qualitatively new property in physics, active information. So Bohm is really giving an ontological interpretation to this quantum potential. Okay, so it's, instead of being just something you want to throw away, you say, no, actually, this is telling me something new about the nature of the world. Okay, with the second problem, which is the multidimensionality, we could just look at very quickly about the many-body systems. What's characterizing one example would be superconductivity, where then if you do this picture, you can see that the many-body wave function and the quantum potential arising with it will actually coordinate the individual electrons so that they are not scattered by obstacles. And Bohm would even talk about here a coordinated movement that resembles a ballet dance, where the many-body wave function is like the script, which determines how you dance. And here, for example, is the way that in superconductivity they will go around obstacles, raise the temperature, and then you get resistance because they will be bumping into the nucleus. Okay. And you see, and in now, okay, so the temperature goes up, superconductivity disappears. In terms of Bohm theory, this is because of the wave function breaks up into a set of independent factors, which then represent independent pools of information. So then, eventually each particle might have its own private pool. Whereas before, they were all guided by a common pool of information. And so it was a common pool of information, the many-body wave function, which gave the coordinated. And now they are all individuals, and we lose this feature. You see, okay, so the information can be in one pool or divided into dependent pools, and this arises from the multidimensional nature of the wave function, where the wave function constitutes one pool when it is not factorizable and many when it is. Okay? And now Bohm is using this to answer key traditional objection to the Broglie-Bohm theory. You see, the criticism, as we have already said, it's that the wave function, being in configuration space, cannot be understood as a field in a 3+1 dimensional space-time. Okay. Well, if people don't, this has been actually an objection to the theory. Now, what Bohm says is that, well, the wave function, he uses this term, it belongs to an information structure that can quite naturally be considered to be multidimensional, organized into as many sets of dimensions as may be needed. So the idea here is that even in a computer, you can, information can be coded into as many dimensions as you need. And so now the idea is here again that, again, when speaking of this multidimensionality, this could open up that, well, in some sense, there could be a three-dimensional energy in three-dimensional space carrying the information, okay? But in any case, it's trying to weaken this notion of a physical, multidimensional physical field. We are now dealing with something more like a carrier of information. Okay, so I mean, that's again something that one could consider. I remember when I first came to Berkeley and had a discussion with Bohm and Hailey, and I'd be reading the stuff and I had all these questions, and I asked, so where is this information carrying? What is it carries this information? And they said, in Swedish they would say det. Just understands that, but they would be saying, well, yeah, tell us. Meaning, so I was very disappointed because I was hoping to get all the answers by, So they were really, I think what they really did say that this is well, we'll come to that anyway. Now, what about these empty wave packets? See, are there bits of reality floating around, interpenetrating the part of reality which corresponds to the occupied packets? It's kind of, strange, spooky stuff. What Bohm and Hailey write in this Undivided Universe, they're saying that they're not denying the reality of the field, but they're saying that its significance is relatively subtle in the sense that it contains active information that guides the particle in its self-movement under its own energy. So again, emphasizing that this is not a usual physical field. And they would say, okay, perhaps the information in the wave function is contained at a more subtle level of negligible energy, in a way hasn't shown yet, and that we have not thus far been able to study. So this is a blanco check, but still, it's a hypothesis that's there's something carrying this information. The essential point is that the information is immensely more subtle and less substantial than the systems on which it acts. So the idea there is that there's kind of almost this is a dualistic claim. The particle is still maybe a bit like with particle properties, and then this wave function is something more simple that's guiding it. So it is a fairly exotic model. And so now when you do the measurement, they would just say that it's a bit the same as Chris was saying, going back to the empty wave packet. So after the measurement, everything happened as if the overall wave function had collapsed to the one corresponding to the actual result, but there is no collapse There's merely a process in which the information represented by the unoccupied packets effectively loses all potential for activity. So there's a notion of inactive information that they're appealing here. And then they would argue, give examples from other areas with information, and they claim that nothing is more common in ordinary experience than for information to lose its potential for activity. And so if we accept that the particle is what responds to information at the quantum mechanical level, it's clear that there is no serious problem with the empty wave packets. So they this is again, they feel that it's really the notion of active information that they feel makes, solves this problem.
Hold on.
Yeah.
Is there what would I call an analogy here with it's only second classical of energy and work, where energy becomes unavailable for work to be able to do something. It doesn't disappear, just that we as human beings or whatever, we can no longer use it. So in other words, this is a bit analogous to what you're saying is that information, it loses its ability to control.
Yeah.
But it doesn't go away.
Right. Yes. Exactly.
That relation between energy and work, I know that's a classical view.
Right.
But it is true that you get energy which we can no longer use. But it doesn't. We don't think it's destroyed.
Right.
No, we just don't. We're not able to use it anymore.
Right. Yeah. No, I think that's the. And I think probably Bohm at these stages, Bohm would then maybe. I actually once, the information paradox with black holes. So I thought Bohm would probably say that information will go and you won't get it back, and this is the way Penrose talks. And then I actually asked Penrose once whether he had, as he thought about the implicate order in that connection, because that's what I think Bohm would say. But then I think Penrose said that he never quite understood the implicate order of my view. But anyway, so but definitely that's the idea that. I think the way Bohm would say that information, it doesn't, it's not, the idea is not that it's kind of completely destroyed, but that it will lose its potential for activity. Anyway, so, yeah. Again, it's the same point again that if we give up the idea that the wave function is what comes closest to describing that which may be called the substance of reality, then the loss of potential for activity will be quite a natural and indeed even an expected feature. So they really ask us to make a move from thinking of wave function describing some sort of substantial field to thinking of it much more as information. And this will be important in the final part, because I've promised as a bonus a new way to understand the relation between mind and matter. So now you can, how do you do that? Okay. Now, you see, Bohm is correct. A certain kind of what he calls activity of form plays a fundamental role at the quantum level. And what he would say is, this makes the quantum level mind-like. He would actually explicit. He said electrons, of course, are not conscious. So he wasn't a panpsychist in the traditional sense. But it's still, moved a little bit toward that, making this kind of claim. And he would say, so what's this activity of form? Well, he would say that's an essential quality of mind, is the activity of form rather than activity of substance. Example, you see, he had various Bohm writing. When we read a printed page, we do not assimilate the substance of the paper, but only the forms of the letters. And it is these forms which give rise to information content in the reader, which is manifested actively in his or her subsequent activities. So you don't need to eat the newspaper in the morning if you want to get the news. You just get the information out of there. And so you see now, okay, fair enough, that's familiar. And there he claims that this is general and fundamental. He would claim that the similar mind-like quality reveals itself strongly at the quantum level in the sense that the form of the wave function manifests itself in the movements of the particle. So it's it's like in the two-slit experiment, like Chris was saying, is that the wave function encodes information about the environment, which is, if you like, fed into the particle, and then the movement. One would say things that the movement is the meaning of information. Okay? And then importantly, you see, this quality doesn't appear to a significant extent at the level at which classical physics is a valid approximation. And the irony here is that in philosophy of mind, philosophers generally try to understand mind in relation to classical physics, okay? Neuroscience, computation implemented in classically describable systems. But of course, if Bohm is right, it's a kind of, why not, if we have matter which has mind-like qualities, why not try discussing mind in relation to that matter? So that's kind of the irony that, and they, people have reasons sticking to the classical level, but this is more just a general point. For a metaphysician, this should be a wake up, because metaphysicians, they can take liberties in their thinking. Okay. All right, so we quickly show you a little bit of the mind matter. This is a quotation again from Bohm. He would say that which we experience as mind in its movement through various levels of subtlety will, in a natural way, ultimately move the body by reaching the level of the quantum potential and of the dance of the particles. He's thinking from any-body wave function, waiting there. Like when I lift my hand, somehow the information at the higher levels reached all the way down and was able to. So of course, this means that Bohm actually thought we extend the quantum ontology to include like what he called the super quantum potential and a whole series of them. And so he would say that therefore there's no, the famous gap between mind and matter is here mediated by information. And he said the important thing is that, there are a lot of various people are trying to explain consciousness in terms of quantum theory. There are many different ways of doing that. Bohm is not reducing mind or consciousness to the quantum level. Quantum, it's only one stage in the process. But it is important because if you think in terms of Cartesian dualism and all that, this is the missing link, you see. So it plays a role, but in what your mind is, maybe at this, what he calls these more subtle levels, and therefore quantum theory may not help you to understand that. It's more just giving you this framework. And this is from another way Bohm used this term soma significance, where this would be a perception where the levels could be the level of the retina, visual cortex, associative areas. So when you're perceiving information, it's being carried into more subtle levels. Over there, a miracle happens, we understand what it means, and then it will kick back to the material levels, or equal somatic levels, physical action. So this is a perception action cycle. I would say Bohm introduces it somewhat differently. And of course, if you want to ask about consciousness, so maybe consciousness would come in at the more subtle levels, but Bohm didn't have very specific ideas about that, so that's what I've been thinking about afterwards, like 30 years, but anyway, I won't go into it today. Anyway, so, all right. So you see, in this view, we understand the relation of mind and body in terms of hierarchy levels, ranging from manifest to subtle. The idea that there is no unbridgeable gap. Why not? Well, because some kind of information is the bridge. But of course, then the question is whether information can truly help us to cross the explanatory gap. And maybe Ron will have something to say about that. But anyway, thanks very much.
Good questions. We have a few questions. Any questions? Sorry. Any questions, anybody?
Oh, just a thought. If you're studying the statue by Anthony Gordon,
Sorry?
I haven't got a picture of it here, but it's on the Thames. he was actually in a conversation with Basil on BBC 4 or something. And when he come out of it, Anthony Gormley, by the way, for those who don't know, he's very famous for this huge iron statue up north. It's called the Angel of the North. But he also has got a statue on the Thames of a similar size. I think it's called something like Emergent Quantum, or words to that effect. Quantum Cloud, is it? Yeah. And I keep it on my computer because I actually, from time to time, I quickly look at it. And this was his vision of what Basil, this was after one died, obviously, was talking about. And it's, I just think it's a very good visual that actually helps, I think, to look at this idea of this information and a human being emerging from it. I don't know if you've ever seen it.
I've seen pictures of it.
in Basil.
Sorry, Mike?
It's on Basil's Wikipedia page. If you go to Wikipedia,
Yeah, no, it's
for
true
Basil,
enough.
it's
Yeah,
on, it's
yeah,
on there.
yeah.
But I guess that's also something like it will change as you move.
Yeah, and it changes as you
Right.
Yeah, no, that's right. Yeah.
Yeah.
So I
So
just
it's,
thought it takes an artist to actually sort of really visualize.
Yeah,
it.
yeah.
It was.
I think it would also
a good one.
illustrate the point that Chris was emphasizing, how in the bone theory measurements are like, they would say they're participatory in the sense that you actually
Oh yeah.
typically participate in creating. So you're not revealing pre-existent values, you're actually.
Just one other thought I'd like to ask you, and maybe Chris could chip in as well. If you go back to the, like I said, the two-slit experiment, and you've got one particle, because we know the experiment's been done where you turn the volume down, so to speak, and so one particle goes through at a time, and yet you still get the pattern, which proves that it's not particle-to-particle interaction. Now, what was I going to say? So, therefore, the quantum potential, or whatever you want, the active information is it's the particle, and you need two slits. That's the interesting thing, is that you need one particle is enough, because it will randomly pop up somewhere, but somehow you need the information from two slits. And exactly why it needs that, I think, is actually this is the only model that I can think of, unless someone can think of something else that will explain it. Because if you drew the same picture for a single slit, obviously you don't get the so-called interference. I hate that word interference, because there's nothing's interfering with each other. It's I wish we'd find something else.
You see, even if you have just one slit open, you will get a little bit of interference from
Well,
the
you
side.
get it if you make the slits narrower and narrower.
Right, okay.
And of course, the criteria, of course, is the wavelength of the so-called wavelength of the part photon or whatever it's going through. If the slit is too wide compared to the wavelength, which you won't see it. So there is this wavelength information coming in. So it's quite an interesting, very sort of complicated way. It's simple when you look at that. It's also a conundrum. There we go. Did you want to
I was going to say, I'm sympathetic, obviously, to these views of active information, but I don't find the analogy of the ship and the radar waves very kind of physical for electrons in a two-slit experiment. I mean, I don't see, surely one needs a mechanism by which that information can impact itself and move the electron, which doesn't have booster jets or anything, as far as I know.
I guess, but they were speculating the source of energy. I guess they may talk about the rest energy or the vacuum energy that. But you see, they have elsewhere in the book, in the Bob Hiley book, they have places where they try to argue. I think there are concrete experimental situations where they argue that you mustn't think of the pilot wave as carrying energy and momentum. And that would be probably one difference with the dynamic universe, because what Tuomo is suggesting is that what he calls the de Broglie wave is actually you know, when you get the spot on the screen, Tuomo would say it's a de Broglie wave and the momentum that is creating that, not the particle. Whereas I think in the case of the Bohm-Hailey, they were saying that this quantum field is not, it has a small energy, which is also important in the mind-matter business, okay? But it's a negligible energy, and so therefore you need something else for the. But this is something, of course, that it would be nice. And I'm puzzled by how if you're using this idea of active information, like, you know, how does non-locality work, or this, like, you know, what Chris was telling us about configuration space, whether how do we, what happens when we say that that we think of this as information being the multidimensional entity. But we can talk about that maybe.
I think I wanted to comment on that. I thought in Undivided Universe, they make the argument. They claim that they think there's some kind of substructure to an electron,
Yeah.
Which will explain ultimately why the active information works. So I think they think there is some kind of mechanism.
You've got to be
that-
careful
Yeah.
with that statement. And I'll tell you the reason why, because there was a research program, whatever you want to call it, analysis. This was on the Big Lep experiment, which was a precursor to the LHC, where they actually did look for the electron having a substructure. There were lots of theories around the time. One was called Technicolor, as I recall, but anyway, that's by the by. It was all based on a sort of quarky kind of idea that some particle inside, but no evidence for what they looked for was that the electron would actually have an intrinsic excited state. Because if you had substructure, if you rearrange it, it would have that would be a different energy value. And in fact, I used to know the guy who did it. His name's Mike Green, not the guy who did string theory. This is Mike Green from out of Royal Holloway. He was the head of department there, and that's where I studied and signed. I know him very well. And he led the team that actually looked for this, and they found nothing. And also bear in mind the latest BDM results, that's the electron dipole moment results, which is still a null result. It's now down to about 10 to the minus 28, 29. These numbers change, so you know. But all this seems to imply that the electron doesn't have.
Right. What about the work? What work of
Okay?
There's still some distance to go.
Well, that is true, and in fact, the Planck length, if we take it at 10 to the minus 34, are we talking meters? The interesting point is, of course, is that particle physicists, which I sort of count as one, we think of the electron as a point particle because of this, what I've just said to you, right? Because the interesting thing is, if you take the Planck length, if it's a point particle and therefore it's dimensionless, it would be smaller than the Planck length, wouldn't it? So therefore, like, I don't know the answer to this, but I'm just saying, you know, be careful when you go down that one. It has been gone down already.
Yeah, no, I don't think I would agree with the idea that the electron has substructure. I'll just bring it up as.
Yeah, no, I'm just saying that
What about the work of Hans Demmelt?
Sorry?
Hans Demmelt, I don't know if he got the Nobel Prize at some point for this work. I mean, he has some ideas about the electron having an internal structure, but
You don't give me a reference to that.
okay. Yeah.
It's a long time ago when I've heard all this up,
Okay.
I'm afraid, so all the names have shifted out my brain now.
I think I'm more inclined to want to argue that the act information is somehow probabilistic. So it's almost in some sense subjective. It represents the probability. It gives information about the probability via the quantum potential without having an active influence on the particle. Or rather, I think I want to think of the particle in the Brownian mechanics as being some kind of conceptual approximation. And the whole wave function quantum potential as a improved way to calculate probability.
Can I make a comment?
Yeah.
This is Basil and I have talked about this quite a lot, obviously. Well, every Tuesday. In fact,
Very good.
anyway.
Yeah.
What's
That's good.
Yeah,
Shall we ask? Yeah.
sorry? Do
No.
you want me to go and ask Basil?
Yeah.
No, I know. I think Basil, of course, they work with the quantum blobs. I mean, he wasn't happy with the notion of particle, but
The
we.
point I was trying to make, Pablo, sorry,
Yeah.
is that, like the LHC, as I described earlier, has come up with some very interesting results. But we have to remember that is, what you just said, Chris, prompted this thought. We have to remember that is only at the scale of about 10 to the minus 15 meters, or 16, that kind of order of magnitude. Now, if we talk about 10 to the minus 34 as some kind of lower limit, if one thinks of it that way, then you've got nearly 20 orders of magnitude between the two. So I think there is lots of space, as it were, for all the sorts of thoughts that you're having to actually manifest themselves. There's lots of space there. It could be 10 to the minus 25 or whatever, I don't know. But it's, there is a lot there. And in fact, when you consider the universe itself is only, I think it's 10 to the 26 meters or 30 meters or something, 10 to 30. Well, actually, there's almost like a universe there for us to explore between where the LHC is at, which is the one down to the smallest scales. I don't think it's an experiment, just going smaller than that, to, this plate scale or whatever limit you want to place on it. So there's plenty of space there, plenty of place to go and look.
But not enough money.
But not enough money,
Right.
and also I'm running out of brain power. I'm not sure. I need a glass of wine.
Yeah, very good. Okay. But shall we ask Ron to give some comments?
So this is commentary on the bonus section of Pablo's talk. That is, I'm going to be focusing on how to what extent active information that was independently motivated in order to solve problems in physics, how well can it perform this task that Pablo highlighted at the end of bridging the gap between the physical and the mental. So the focus is on active information, and I'm going to construe the problem of consciousness, the problem that's trying to be addressed, as the problem of the subjectivity of consciousness, or the subjectivity of mind, versus the objectivity of physics. And the proposal that I want to make is that we can analyze subjectivity as being complex of 4 properties of mind-like states. And the claim will be that active information or systems involving active information exhibit these 4 properties, the PI3 properties that I'll explain later, that are a good analysis of what subjectivity amounts to, or at least part of what subjectivity amounts to. So what I'm going to say is, so I have to give some perspective. I've been debating with Pablo and also Basil about these things for decades. And traditionally my role has been that of the constructive critic. So skeptical about the role that say anything from quantum mechanics might play in explaining mind. But what I'm going to do today is say, well, what if they're right about what active information is? Then can we actually use that, assuming they're right? Can it actually do the job that Pablo highlighted? Can it actually explain the mind in some sense, or bridge that gap? So that's the role that I'm playing here. I'm more, maybe today, much more open to the possibility that it could perform, that active information could perform this task than I have ever been in my intellectual life so far. And so that's what I'll be focusing on. What's the central problem here? It's the subjectivity of mental states like consciousness versus the objectivity of physics. So, following Dennett's 1988 paper, Quining Qualia, these qualitative states that constitute consciousness can be seen to have four properties themselves that make them difficult to incorporate into a physicalistic worldview. And that's the fact that they're private, ineffable, intrinsic, and immediate. By private, I mean that only the subject of consciousness has direct access to the precise character of conscious experiences. And that's at odds with the objective, or at least intersubjective character of science, and therefore physics. So these are objections to a scientific account of the qualitative character of experiences, or qualia. Not just the physical, it's actually any scientific account has problems with these four features of the mind. So privacy, that's the first one. Then there's ineffability, which is just not being able to communicate these states. The precise character of conscious experiences cannot be expressed in language, which blocks the normal, that is, public scientific theory construction, testing, falsification, etc. That seems to be a problem. The intrinsicness of these qualitative states is also problematic. What do I mean by intrinsicness? The character of a conscious experience appears to be what it is intrinsically and not by virtue of any other fact. So what this feels like to me right now, the qualitative character of my experiences right now, it seems that it's irrelevant what the causal history of these experiences are, or what they will eventually do. They have their character independent of any connection to anything else, say causally. And that prevents our usual methods of scientific explanation, which normally proceed by citing and examining these kinds of causal and relational factors. And finally, the fourth obstacle to understanding these qualitative states of mind scientifically, and especially physically, is that they are immediate. And I don't mean that in a temporal sense. I mean that in the sense that it's our knowledge, the subject of the experience has an unmediated knowledge of the character of that experience. So the subject doesn't have to perform a test or consult anything in order to find out what the qualitative character of their mental state is. And that also seems to be a problem for getting a scientific handle on the character of these experiences, because there doesn't seem to be any process there that can be investigated. I won't go over active information. Pava did that very well. So I'll just skip this slide. I'm just I'm pretty closely following, say, Hiley and Pulkkinen's treatment in their 2022 paper. So what might active information say about privacy? Well, I'm just going to use Hiley and Pulkkinen's treatment to just highlight that they themselves found it's odd. And well, I don't think it's entirely. I don't think they explicitly had this Dennettian analysis of qualia in mind when they wrote their paper. So they didn't think, oh, well, we've got to mention privacy in here. We've got to mention intrinsicness in here. We've got to mention, because that's part of what it is for. That's part of the character of conscious mental states. But the fact is, there already is a notion of private being employed by in the notion of active information. There seems to be a sense in which, especially when you have groups of, with many body systems, in which the quantum potential, say, for one of those groups is private to that group and is not accessible by, say, another group of particles that are even in the same environment. So it seems to be that the quantum potential there's a kind of privacy there that offers, some it's suggestive. I'm not proving anything here, but I just find it suggestive that there's a kind of privacy here that might undergird the or support a kind of privacy of the kind that we see with qualia as well. Ineffability comes for free. If X is private, then X cannot be communicated. So I'm not going to say much more about that aspect of Dennett's analysis. What about intrinsicness? Well, again, thinking about the same example as before, this is just a little further on in Heine and Pulkkinen. They themselves mention that that there's an intrinsicness to the way in which the configuration and the situation is informing any of the particles in the system it's not mediated by any force. It seems to be a direct kind of what they call formative causation, like an Aristotelian notion of formative causation, where you actually have the it's hard to describe, but there's a way in which the behavior of the system is directly shaped by the environment and not something that it can be understood in a classical Newtonian way of some kind of mechanical push and pull. And so that is what Dennett is trying to capture when he talks about the intrinsicness of, it seems to the fans of qualia and these conscious states, that they have their character intrinsically in such a way. And so there seems to be, again, another parallel here between the kinds of ways of understanding the very basic physical reality and the ways that even a critic of conscious mental states, as in terms of qualia, the way that he conceived of them. And finally, immediacy, which is closely related to, again, like we had with ineffability and privacy, it's kind of a byproduct of intrinsicness. If there's intrinsicness, then in some sense you have to have immediacy. You also see that in Heine and Pulkkinen. You don't appeal to a pushing and pulling of the configuration upon the particle. Rather, there's a direct informing of the particle by the quantum potential, and this is the character. This is a hallmark of active information as they conceive of it. And I'm reluctant to go into this issue about misrepresentation that I mentioned here. I have a slide after this one about it, but I think there will only be two people in the room who would know what I'm talking about, because it refers to earlier debates that Paavo and I have had. But all I'm saying is that in the past, I used to think that limitation of the ability for active information to explain the mind was that it was more like, it isn't Shannon-Weaver information, but it's more like Shannon-Weaver information than the kinds of representational contents we usually associate with the mind, in that it couldn't be false, it can't be false. So that you don't have a case of the particle being informed by the quantum potential inaccurately. We can't be told that there are two slits open when there aren't two slits open, right? And that, to me, when I wrote about this before, was a big gap between the kinds of ways in which we are engaged with our world as mental beings and the kind of information that was in play in these kinds of systems. So I wrote, look, they don't really involve, even in active information, you don't really have content in the sense of representations that can be true or false about the world, and therefore you're not going to get very far with understanding, in terms of understanding the mind. But when we're talking about qualia, you do have a kind of incorrigibility, a kind of inability to be incorrect, that is actually turns this into a feature rather than a drawback. And now I see that the hallmark of the presence of a mind could be in that you need to talk about a way of thinking of the world that is different from the way the world is. A seems is distinction, but there is another route that Bohm and Hiley and Pulkkinen are drawing our attention to, which is this being informed actively by one's environment. So even though there's no possibility of error or misrepresentation, the fact that the configuration can directly be informing the particle is a hallmark, I think, of mentality, in the sense that we have something that philosophers refer to as aspectual shape. So it's the particle, the configuration, qua the configuration being this way or that way, is the particle is registering the world as containing two slits, or two open slits, or one open slit, whichever the case may be. And that in itself is a hallmark, I think, of mentality, is having some ability to respond to the world according to these quite abstract, different spectral shapes. So I'm rethinking my criticisms from before. So I come up with this chart, which characterizes the kind of position that I think is being expressed by the active information view, and contrasting it with some other views about qualia and physicalism. We have the standard kind of dualist view. I call it naive qualia realism. Qualia do have these four properties that I've mentioned. Those four properties are not compatible with physics, but qualia do exist. Therefore, physicalism is false. There's something more than physics, because physics can't handle qualia, and qualia exist. There's another kind of position which is attributed to, with say, Keith Frankish and maybe Dan Dennett would favor, which is qualia, if they existed, have the four properties that I mentioned, but those four properties are not compatible with physics. Therefore, qualia don't exist because physicalism is true. Then there's a position that I put forward, and along with Aaron Sloman, which is qualia don't actually have those four properties. Some people think they do, but they actually don't have it. So even though those four properties are not compatible with physics, that doesn't cause a problem for qualia existing, even if you're a physicalist. So it turns out to be an empirical issue, whether or not qualia exist. It's just they don't have those four properties that Dennett said you have to say they do if you believe that they exist. But now we get down to these last two views. I'm going to skip this one and focus instead on the active information view, which says, which we now can see allows one to say, yes, qualia really do have those four properties, but those four properties are actually compatible with physical reality. We do find subjectivity of that kind, privacy, immediacy, ineffability, intrinsicness. We do find primitive forms of those kinds of subjectivity in some quantum systems. And so we can have, we have no incompatibility between qualia existing and physicalism being true. So am I saying that anything goes? And when I say that there's a subjectivity at the root of physical reality, am I saying that it's all subjective? No, I don't mean subjectivity in that sense. And when I say I don't mean that, I also don't think that, I know that Hiley and Pulkkinen and Bohm don't mean it that way too. So the subjectivity at issue, we're not talking about subjectivity for the theorists, like a subjectivity, different theorists can disagree on the way the world is, and the world supports that in a relativistic way. In a relativistic way. Rather, the subjectivity we're talking about here is the subjectivity for the particle, or for the particle system itself. And that is an objective physical fact that there is such subjectivity there. So the theorists, there's a truth of the matter, physically speaking, about what kinds of subjectivity are present. And I think confusing those two, the subjectivity that causes relativism seems to make relativism threatened, and the subjectivity that we're trying to account for when we try to give an account of consciousness in a system, I think confusing those two likely contributed to the belief that physicalism and subjectivity are incompatible. So am I saying that quanta have qualia? No, I am not saying that quanta have qualia, and I'm not saying that Hailey and Vilkinen and etc. are saying that either. What I am claiming is that there have been several arguments against physicalist accounts of qualia that assumed that these four properties were incompatible with or could not be found in physics. And what I tried to show is that active information gives us good reason to question that assumption, that actually maybe you can find these four properties, what I analyze subjectivity into: privacy, immediacy, intrinsicness, and ineffability. Maybe you can find them even at the lowest levels or at the level of quanta. And so even if you need more than that kind of subjectivity in order to have consciousness present, still it's a big step forward if you can show that subjectivity and this proto form of consciousness, proto form of qualia, can be present even in quanta. And also, there's no reason to believe that whatever you do have to add to this subjectivity in order to get true qualia or consciousness, there's no reason yet to believe that this something more must be non-physical. So finally, I want to say this, that even if it turns out that we don't have quantum qualia, that is, even if active information doesn't play a role in our brains that explains why it is that we have subjectivity, etc., and eventually consciousness. One interesting idea is that, well, maybe we could design artificial quantum systems that do exploit the four properties that I mentioned, the PI3 properties in quantum systems, in order to achieve some type of capacity to deal with the world. So why can't we create such systems, even if the operation of our brains is not exploiting active information in this way? It seems like we could create artificial systems that do exploit active information in the way that I've outlined. So they could have quantum qualia even if we do not. That seems like really an interesting speculative possibility. So I focused exclusively on the quantum potential approach. So I should ask, what solutions or challenges might the dynamic universe approach offer someone trying to understand the physical basis of mind, and how much of what I said earlier carries over to the dynamic universe view? I have no idea about that, but I thought there might be something interesting to discuss. So that's it. Thank you.
Thank you very much.
I'll just comment quickly. So yeah, I have the mic here. So thanks very much. I think this last thing was very fascinating, especially fascinating about having, because there's a big discussion about whether these quantum approaches to consciousness, or Penrose and Hameroff have a view, and so I think that the idea that we might not have this quantum quality, maybe artificial. That's really, I think that is a very cool and a new idea. But I guess the one comment I would have is just that whether this needs to be like a physicalist picture, because actually I'm currently writing a paper connected to David Chalmers' views, and it's about reductionism. And of course, with Chalmers, there's the idea that information has it's a dual aspect theory of information. So information has these phenomenal properties and also at the same time physical properties. And I think Bohm had something similar with, he would also say that information is simultaneously mental and physical. So and of course his whole business about this soma significance was saying these are two aspects. So I guess I'm still somehow attracted by a non.
So I have a way of dealing with that. So in a way, it's what are we going to use the term physicalism for? Are we going to? And And so here's what I offer as a way to look at it. What I'm really interested in is whether the theories and concepts and ideas that we need in order to understand physical phenomena, whether they are all that you need, or whether you need to have something else. And if somebody else might say, but look, when you're, and if because of what we've seen with the quantum potential, you need more than mechanical push and pull. I'd say, okay, that doesn't mean that we've left physicalism. It just means we realize that physics requires more than mechanical push and pull. So in order to avoid talking past each other, let's just say materialism, or let's say mechanism. So I can say that what we might discover here is that a materialist worldview won't explain the physical or the mental. Or we might say a purely mechanistic worldview won't explain either the physical or the mental, right? But the point is that whatever we do come across, or whatever we do settle on, will be a set of principles that explain both physical reality and mental reality. We don't need anything more. What we need in order to explain the universe at the lowest level is all you need in order to explain the universe. So that's what I'm holding out for and most interested in seeing whether it works. I'm only going to reluctantly have to say, yeah, we've now got all the physical sorted, but in addition, in order to understand consciousness, you have to add in some other stuff. That's, I mean, I don't just mean add in more concepts. I mean add in something that is incommensurate and ununifiable with that way of understanding the base reality. So, yeah, I think we don't want to let the terminology make it look like we disagree when actually we agree.
Okay. Any other questions? Owen, yeah, you can.
So,
Wait.
I think there were 2 points I was thinking listening to it. The
Few
first,
points you were what?
there were 2 points I was thinking listening. The first one was, I feel like what this shows is that quantum act information functions in a kind of an end of a hair, like Chuomo was saying, like a formal cause acting on the particles, which is, by analogy, in Aristotle, the soul is the entelechy of the body.
Right.
So I suppose there's that link going on between the two.
And that seems to fit in with the soma significance that Pablo was talking about. Yeah.
Yes. The other point, I wasn't convinced by the ineffability.
Okay, all right. I thought that was the easiest one. That's why I skipped over it, but maybe I shouldn't have.
Okay, because if you imagine 2 billiard balls colliding, the experience of being collided on the part of one billiard ball is private to that billiard ball. And by that definition, by your argument, that would therefore be ineffable. But I don't know, would you want to say that every collision between particles is ineffable?
Okay, so I'm glad you asked this because it lets me go one step deeper to explaining how this works. So what we're talking about when we're talking about private knowledge or ineffable knowledge is a subject's knowledge of their own qualitative state. So we're not saying that anybody has private knowledge of the world or ineffable knowledge of the world. We're talking about whether they have private knowledge of their own conscious states. And it's a bit tricky, like it is in the active information case, because there's a kind of self-reference here. There's a kind of auto-constitution case where my own states are themselves constituting my knowledge of my states. But anyway, let's just talk about the knowledge that I have about my own experiences. So I'm trying to say that the active information can help us model that very specialist kind of knowledge, the kind of knowledge that we have. Our experiential states seem to us to be private, and seem to us to be ineffable, therefore. So I can't really communicate. I can't tell anybody what my experiential state is, because that they could only know what it was like if they could actually be in it, and the way that the way conscious states are such that only I can be in them. Only I can be in mine. and nobody else can be in mine. So the idea here is that maybe that special kind of knowledge can be modeled by what's going on with the particle being informed by its environment. So if you have a system whose self-knowledge is somehow realized in the knowledge that the information that the particle has about the configuration, then you will have a case. I'm not saying I've solved that. I don't know how to build that. But if you could somehow make it so that that kind of knowledge that the particle has about the configuration realizes some artificial, perhaps agent's knowledge of its own mental states, then you've succeeded in giving it at least some of the necessary conditions for quality. You've given it private states, and therefore it won't be able to communicate. It'll be ineffable because it can't get some other robot into exactly that same configuration. Maybe something similar in some kind of equivalence class sense, but it won't be the very same empirical relation, right?
I think I definitely agree there's the analogy there, because I think it's coming through the formal causation. And I'm less common. I still think it's like the key point about qualia or the mind is the fact it's self-constituted. And I think the question is, do particles have self-constituted states?
We could ask Chris, say, when you're computing your trajectories, see, there's the configuration space, but there's also the particle itself has to be taken into account, right? The particle is part of the configuration, isn't that right? So that's why you can't map them out independently. So yeah, the split being open or closed, that's part of the conditions that determine the quantum potential. But the particle itself is part of the boundary conditions, or what you need to use to calculate the exact shape of the quantum potential in this case. You have this self-constituting, right? Isn't that like? That's why it's a formative causation. That it isn't like there's a mechanism going in and saying, okay, now that the slit is over here, then communicate that information by the means of this ray or this other particle, and tell that particle to move. Because no, it's direct. It's a directly constitutive thing where it's a direct formative causation, and therefore AI systems that exploit it have the potential to be massively efficient and low energy because you don't need any wires to communicate the information about the different variables. They actually formatively cause the behavior of the system. That's a talk I gave a year ago. And I was thinking,
I feel like I've still got questions. I reckon it might be a good idea to let someone else answer.
Mike?
There's a very slight danger here in this exchange of taking the ineffability, the notion of the ineffability of anything, in fact, of confining this notion of ineffability too much to this sole aspect of
I hope you mean SOLE and not SOE.
No. Absolutely. No, sorry. No, my worry is that this is confining ineffability a little too closely to the notion of, to the subjective side of unavailability, inexpressibility of content. There's something more, it seems to me, that's involved here. Inaccessibility. Yes, that's confining it too much to the notion of inaccessibility. Inaccessibility, and this is placing things very much on let's say, the epistemological side. There's also, and this is particularly true about the whole notion of the ineffability of semantic content. The whole issue of the kind of closure of one's categorical system of reality. There's an objective side, the question about whether this is something which, in principle, can fit within what we think of as the categorical structural system, what it is that, as it were, provides our sense of these being the resources that closes the space of explanation. possible concept formation. There's something more in the case of, say, if there's the sheer ineffability of semantic content. There's the idea of ineffability of semantic content as something that, in some sense, is there determinate in advance. This whole matter of having states of representation whereby we think our thoughts as being true or false of something, that implies that the semantic content is somehow something determinate in advance, available to be tapped off reality from the outside, rather than as something for preconditions for the very formation of which, the very possibility of formation of which, somehow grow from within the system. And that seems to be a fundamental distinction, which goes beyond simply this question of it's an accessibility. It is more than just the privacy issue involved.
You're right. So, for example, just to agree with you, one of the reasons why experience might be ineffable is because of its richness. So I have this very rich perceptual experience right now, and I don't have concepts that are fine-grained enough to communicate to you. But I can get a start on that. I can say, yeah, I see green here, and there are these surfaces and people, and I get a lot of it, but I can't get the exquisite detail. But that doesn't seem to be the same kind of point that I was making when I talked about active information. So you're right. There might be other sources of adding to ineffability that are more, I would say, more pragmatic, that have to do with like computing limitations. Why don't I have fine-grained enough concepts? Well, because they wouldn't be useful to have because they can't be used in any other situation other than this, and it would require a large degree of calibration between us, and there are all kinds of practical reasons why maybe I can't communicate this experience. But I was talking about something that goes beyond practical to principle ineffability that seems to be a feature. I mean, people wouldn't be happy if I just explained that kind of ineffability. They say, okay, maybe you have shown that that's physically realizable, but there seems to be a deeper ineffability, and I think physical science might be able to.
So I have more in mind the characteristics involved. The very thought of semantic content is involving the very notion of representations which have to be true or false of. I mean, there's obviously any number of complexities here that the truth-bounded gaps, whether or not admitted in our logic, but the idea that we can think of semantic content as somehow the starting point. It's the idea really that we've had really in philosophy, really ever since Hegel, that the theory of meaning is the starting point for first philosophy. Now, I actually have to think that's dead wrong. We've actually got to go back to the more to the previous way of actually trying to understand the very conditions of the formation of semantic content taking place in a world in which you could, in principle, have a unified naturalistic conception. But that's to go off in very, very widespread, then taking us a long, long way afield. But I just think that what you're touching on here is some of the deepest issues in the whole of science. So, I'm sorry. Well, obviously, to be continued.
Yeah, exactly. Yeah. Right. You have another question?
I'll definitely say on that. I think there's a sense in which I think in a metaphysical sense that reality is beyond meaning or beyond being is prior to intelligibility. I mean, I'm coming at this from a beginning point of view. Like the one is before the logos is before the process. But I think you can interpret it semiotically, for example, through Pierce or someone. The item or the thing itself is prior to its symbolic representations, which are prior to the process of identifications. So it seems like, in that sense, quantum information belongs to the realm of the logos, not the realm of the one.
But I think that works in my favor for what I'm trying to do here, because I'm not trying to give an account of the way the world is, the Ding an sich. I'm just trying to explain how can it be for us to have our conceptualizations of the world, our experience of the world, and how can that be realized in a physical system? And people have said that consciousness can't be realized in a physical system because it has these four properties. Yeah, the quality of ends. So the people go two different ways. It's not just the polyphens, it's also the illimitedness. So the people that I'm fighting, there are these ghosts in the room that you can't see, and one of them is Dan Dennett. I'm basically saying we don't have to eliminate consciousness because it actually turns out that all those four properties can be found in physics. And I'm also fighting against the other ghosts like old Frank Jackson or Descartes or whatever, or maybe even Dave Chalmers sometimes, who's saying, no, you don't have to believe in you don't have to have a dualistic worldview because you can actually find those four properties that you thought had to be non-physical. You can actually find them in even the lowest level physics, or at least we have an inkling of that you might be able to find. So maybe there's more, maybe some of the things that I analyzed can be given better explanations, but that you still don't see any reason to think that it requires a dualistic explanation.
No, I wasn't suggesting.
So I was just maybe overreaching and saying active information can give you all four of these. Well, maybe it turns out that one of them, for example, ineffability, that maybe there's a better explanation that doesn't use active information. But I will have lost that battle, but have won the war. It still turns out to be that physicalism is still on the cards. And quality realism is still on the cards.
On that note, good night.
Thanks
Thank
for
you very
the
much.
questions.
Everybody, thank you for your talk.